Hi, let me start with introduction. Students often face difficulties in understanding the operating principles of electrical circuits, where they are commonly confused about the functions of components, particularly the contactor. The most confusing part for students is the concept of normally open, no, and normally closed, NC, contacts, as well as the function of terminal symbols A1 and A2 on the contactor. For the project objective, 1. To clearly understand the actual function of the DOL Starter 2. To identify and differentiate the roles of key components such as the contactor, overload relay, and push buttons. 3. To build confidence and accuracy in HVAC wiring activities. This project involves a complete design process which includes drafting and drawing using AutoCAD, designing the DOL, direct online, wiring diagram, and producing the actual working product. Curious how it works? Let's find out together. First state is when we switches to number 1 and 4. It's to indicate the condition when no current is supplied to the contactor coil. Push button on is pressed, green lamp and OLR, 95 to 96, light up. This shows the connection from switch to push button is correct, even though the contactor is not yet active. Second state is when switches to 2 and 4, DOL starter circuit is functioning correctly, with the contactor energized. When push button on pressed, indicator lamp at terminals 13 and 14, no, lights up. This indicates that the circuit is completed through the normally open, no, contact. This condition shows when the contactor coil is energized, it generates a magnetic field that pulls the contacts downward, thereby completing the main circuit. The last state is switches 2 and 3, indicate that the circuit is in a trip condition due to an overload or fault. This is because the circuit is broken, the contactor coil is de-energized. The magnetic field collapses, and the main contacts open. Terminal 95 to 96, normally closed, opens to interrupt the circuit. A red lamp or trip indicator turns on to alert that the system is in a trip state. By using a visual and hands-on approach, this kit makes learning more engaging and enjoyable. It bridges the gap between theory and practice, increases student interest, and improves comprehension in the HVAC testing and wiring course. The conclusion is this innovation shows great potential to be expanded to other topics, supporting both student learning and instructor creativity. The hands-on interaction promotes active learning, boosts engagement, and increases knowledge retention. It also builds student confidence in wiring tasks and troubleshooting, which are critical skills in the refrigeration and air conditioning field.